discuss the open system interconnection model, or the OSI model, which is split into 7 layers. The top 3 layers represent the software that make up the network. The bottom 4 layers represent more of the hardware functions, such as the hubs, wires, IP addresses, cables, and so on. We split the OSI model to 7 layers. I always like to draw a box. Okay. And the first layer is the application layer. It's the top layer of the OSI. This layer is the communication to the software applications of a system that provides services of a network to a computer using a DNS, or domain name system, which is a database of stored IP addresses of other PCs that use, well, it uses them to communicate with other PCs. Hence, the application layer is when you're entering your message or search into a web browser, such as Firefox or Google Chrome. Again, this is a web browser. Okay, the second layer of the OSI is the presentation layer. This layer translates the data that you input into the correct format so it can be shared with the rest of the layers of the OSI model. Translates the data.
Go.
The next layer in the OSI model is the session layer. This is where communication is initiated, kept open, and closed. We could also call this layer the knock knock who's there layer. The layer after session is the transport layer. This layer uses transmission control protocol, which is also known as TCP. TCP is part of the TCP/IP protocol. The transport layer manages the flow of data between end users. It segments and reassembles data packets and does error detection and recovery. This means that the transport layer can keep track of the segments and retransmits those that fail. The transport layer also provides acknowledgement of the successful data transmission and sends the next data if no errors occurred. An easy way to visualize the transport layer is to compare it with a post office, which deals with the classification and delivery of mail and packages.
Now, in between the transport layer and the next layer, which is the network layer, you have what are called firewalls. Now, Firewalls can either be hardware or software, but they act as sort of a guardian between your home or school or work network and the rest of the internet. And the way they work is that when a data packet is sent to you or you send out a data packet, sometimes there's a flag added to it. Now, if your firewall recognizes that flag as something it doesn't like, it won't let that information to pass through the firewall. After it passes through the firewall, you enter the network layer. And in the network layer, you have things like IP protocol, and routers. The basic purpose of the network layer is to provide a means for the transfer of data between networks. Where was I? Oh, the network layer also provides routing functions, and such obviously includes routers. Now, the point of a router is to take in information and connect that information to another network. So if you were to send out, let's say, information to Malaysia, what it would do, what the data would do, it would hit your router with a flag or with a header on it with its destination, and it would go from router to router until it reached where it wanted to go. Kind of like air traffic control, determining where information should go and where it currently is.
Okay. The second layer of the OSI model is the data link layer. The purpose of the data link, The purpose of the data link layer is to provide communication between different machines that are connected by a single communication channel. This layer is also responsible for the final encapsulation of messages into frames that are then sent over the network at the physical layer. The data link layer is also the last layer that is concerned with addressing or labeling information with a destination. MAC addresses, which are unique numbers assigned to individual computers, are used to direct messages to the predetermined location. All these messages are sent across the physical layer. The physical layer is the first level of the OSI model. The physical layer includes all of the networking hardware used in a network. This would include hubs, the cabling, such as Ethernet. The physical layer doesn't actually change the data, although the way it is transmitted may vary. Data can be transmitted over twisted pair cables, fiber optic cables, or even wirelessly, each of which use a different method of transporting the data. These different methods would be copper wiring, light, and air.
This is what happens during the OSI model when you type something into your computer. You are the end user. So you use your browser, you type in your information, and it goes through the OSI layers in order. Right here is ARP, Address Resolution Protocol. That's where your IP address is changed into the MAC address. And it comes over through the cabling, whether it's fiber optics, wireless, or cable. It's the other person's physical layer. Right here is RARP, which changes their MAC address to an IP address. And it continues up layer by layer, the OSI model, till it gets to the other end user.
Did you know that a network is separated into 3 simple connecting units? A hub, oh my. Hub, a switch, and a router. Now there are other ones, but these are the most common used say in your home or business. Now a hub, let's say you have 4 computers on your network. In the middle is your hub. Now hubs are pretty stupid. Okay, if you're connected all through the hub, now let's see, PC1 wants to send some really cool pictures to his coworker, PC3. PC1 send this message to the hub, intending for it to go to PC3. The hub doesn't know that. So it takes that message, sends it to PC4 and to PC2, along with PC3. But this is, as he said, stupid. Why not have something that takes your message and sends it to the PC you intended it for? And that's why you would use a switch. Again, we'll have 4 computers. Excuse my drawing. Switch. And they're all connected. This time, PC1 wants to send a picture or any type of data to PC2, or 3, excuse me. You'll send it to the switch. Now the switch remembers the MAC addresses of all the PCs on the network. So it learns and it remembers. Now, it knows that PC1's message is intended for PC3. So, and it pulls PC3's MAC address. Oh, this message goes there. So it sends it to PC3, not to PC4 or PC2. Now, talking a little bit how networks are split up and how big they are. These 2 networks is what I'm going to call a LAN, or a local area network. Now, to connect to the 2 networks, these networks use what we call a router. It's what networks use to connect to other networks and to connect with the internet as a whole. Now this connection right here, these two networks were connected, say it's 2 separate office buildings in separate parts of the country. This would be called a WAN, or a wide area network. So this is pretty much what a hub, switch, and a router does, and what a LAN and a LAN is.
You're all ready?
Yep.
You're recording me saying this right now?
Yep.
That's good. In between the transport layer and the next layer, you have what are called firewalls. And not the movie starring Harrison Ford, right? Harrison Ford? I should probably start over.
Talking a little bit how networks are split up and how big they are. This network, or both of these networks actually, would what one would call a WAN, or a wide area network.
No.
Stop. Edit that.
Yeah.